Okay, so my earlier video goes into some depth explaining the intuition of an ANOVA. But some people have asked me, more directly about these problems on the homework. I think that if you watch those videos closely, you'll get a good understanding of how ANOVA works. But really, to complete these problems that are on the homework assignment, I'm encouraging you to use the Excel data analysis tool pack. So a lot of the calculations that I did there were really to demonstrate how exactly this comparison of variance among all the different components, how that actually works. But as far as like shortcuts go, if we're really just trying to do the analysis, then Excel provides some nice shortcuts, and I'll show you how these problems really aren't maybe as intimidating as they first appear. Okay, so I'm on problem number 5 on MSL4, and I'll just go maybe just the first couple parts just to get you started on it. But so we've got this data that's given to us here, where it's giving average sales for each of these different food segments. We got burger, chicken, pizza, and sandwich. So we've got, so we've got 1, 2, 3, 4 different groups, right? And then the units that are actually being collected are the average sales, okay, for each of 38 brands. Okay, so before we get into this, let's just go ahead and take a look at the data, and I think you'll see that it's in a not very convenient format to work with as compared to the data that we've been working with so far. But I'll show you it's not very hard to just, with a little bit of copying and pasting, to just get it in a format where we can very quickly do an ANOVA of it. So first of all, I'm just going to get rid of this first row here, and you see this has got the actual name of the product in this column, and the sales over here. So I'm just gonna just kind of move this over to the left here. Just I think that's an easier thing to read. I'm going to sort this column here. Okay, so now I've got all of the burger groupings together, all the chicken groupings together, pizza and sandwich. So, so because I want to work with columns, I'm just going to go ahead and make these columns. So this will be where I'll put burger, chicken, pizza, and sandwich. So I'm going to put these, these observations for burger right here. And I'm going to take these for chicken right here, put them there. Now notice that for this analysis, it doesn't matter that we have different numbers of observations. Okay, that matters for the paired samples t-test, but it doesn't matter here. So I'll take this. Okay, so now we have something much more closely resembling the example that I did. Okay, so this will be grouped in a nice way that we can just quickly do the ANOVA. Let's go ahead back to the question first before we do that, though. So let's come back here and take a look. Okay, so it's giving us it's giving me a 0.01 level of significance. Okay, so what we want to know is there evidence of a difference in the mean U.S. average sales per unit among the food segments? So with an ANOVA, remember that your null hypothesis is that the means of each group is the same. So we see that we've got some of these are going all the way up to 38. That doesn't make any sense. We actually have 38 observations in 4 groups, so we're concerned about the means for each group. Now the difference between B and C on my options here is the difference is that the alternative hypothesis should be that they're not all equal, which is not the same as they're all not equal, which is over here. So B is the correct answer for this one. Okay, so now we have to find the F statistics. So remember that what we're going to do is, find a certain statistic that's going to tell us whether we have enough evidence to reject this null hypothesis. And in this case, it's that F statistic. So the F statistic, remember, from the other video, we've got that whole big table where we're calculating sums of squares, and then we're taking the, sums of squares across, sums of squares within, and then we're taking the mean by dividing by the degrees of freedom, and so on and so forth. Now, that's fine that you know how to do that, but we can go ahead and take a shortcut here because the data analysis tool pack will do all of that for us when we do the Excel ANOVA. So all I have to do is just come here, I'll open up the data analysis tool pack, and up here at the top I've got ANOVA single factor, and I will select this range right here. Hopefully I got everything. Okay, and I'm going to say that my labels are in the first row. Now, the alpha that I was given in my question prompt was 0.01. So at the 0.01 level of significance, I'm going to put there. And I'm going to put the output right here so I can see it. I hate it when it does that. It substituted my output selection for my input selection. So let's do this again. Okay, so labels in first row, and I want my output here. Okay, so this just constructed the whole ANOVA table like we've got on the slides and in that other video. We've got our degrees of freedom. Remember that this is the number of groups minus 1. This is the total number of observations minus the total number of groups. So that's 38 minus 4. And so this mean square column is this divided by this. And this is this column, this divided by this. And so the ratio of these two values is our F statistic. Okay, so if I come back here to the MyStatLab, it says round to 2 decimal places, so it's going to be 2.89. 2.89. Okay. All right, so determine the critical value. So let's see, is this, this actually does give us the critical value. Now, the reason why the F distribution is a little bit easier to use than the T distribution is that it's only ever positive. So remember that this statistic is calculated as the ratio of 2 squared variables, so it's never going to be negative. We don't have to worry about tails in this case. So when we have a critical value, this is telling us that we needed to have an F statistic larger than this 4.4 in order to reject the null that all of those means are equal. Okay, so this output gives me the answer to that question too. So how many decimal? 2 decimal places. So 4.42. So 4.42. Okay. So reach a decision. Now I can see that my critical value said at that level of significance, I needed to have an F of 4.42 or greater to reject. It turns out my F stat was only 2.89. So this is not large enough, right? So this is larger than this. So I am going to fail to reject. Okay, so I'm going to do not reject and just say there's not sufficient evidence. Now your answer may be different based on your critical value and your calculated F statistic. That's but that's the answer for mine. Okay, so the next couple of parts of this have to do with the Levene's test, where you're testing for the homogeneity variance. I didn't actually cover this very much. In fact, in class, I didn't cover this at all. We don't really need this. This is not critical. If you're curious, on page 405 of your book, you'll see really this is no more complicated than you're going to come here and then find out how far these are from the mean of this group, and then you'll just do another ANOVA of those values. So that's how you would do that. But I'm just gonna say because I can't separate out these parts of the question from the other parts, just go ahead and put in whatever nonsense there, just so that we can just get through those parts. So that's not, you're not going to be responsible for the Levene's test. But again, that's something that you could do. It's just we're not going to worry about it. Okay. Okay, and then the decision also. Okay, so basically the second part of that, which involves the variance, just don't worry about that. I'm going to add a bunch of points to people's. So if you have a question where it's, so notice that here we are asked about the, we're trying to test the null of the means of each of these different groups being equal. And the difference here with this part is that it's asking you about whether the variances are equal. We assumed an equal variance and never really got into that. So I'll just give everybody credit for those parts and just go ahead and submit what you have. Okay. So I don't know what these are going to be. Okay. All right. And let's see. So number 4. Okay. And number 4 is straightforward. Okay. All right. Good luck with that.